today we'll be covering 60 derivatives, and here are the rules for derivatives. So I highly recommend you to copy this down, and let's get right into it. Question 1. So here are the tools required to solve this problem. So the first rule we got to apply is the quotient rule for exponents. So we're going to present this square root of x as 0.5, and we're going to subtract from the numerator as stated in the rule. Once we accomplish this, we acquire this. Now we distribute this derivative term to every term. We're going to use that by applying the sum rule. Then we're going to remove this 4 from this section and also this 8, and we're going to bring it outside by applying the constant rule. Once we've done this, we can apply the power rule for each individual component. Okay, like over here we take 1.5 minus 1 as stated in the rule, and we put this 1.5 at the bottom, and we acquire this, and this is another way to rewrite it, and that's the answer to this question. Question 2. Over here, here are the tools to solve this question, so we have to apply all these rules. And the first rule is applying the sum rule. We got to distribute this derivative term, and once we distribute it, we can apply the radical exponent rule, which will rearrange this as follows. Then we can apply the constant rule with this 4. We take it outside, and then we can apply the power rule on both sides. So we take this 1 divided by 3, bring it on the bottom, and subtract it by 1 in the exponent. So as you can see over here, we acquire this, and that's the answer to this question. Question 3. Here are the rules to solve this question. So apply all these rules. The first step is by applying the sum rule, because we got to distribute this derivative term to every term inside the bracket over here. Now once we do this, we got to apply the constant rule to move this negative and this 2 over here. So we're going to apply it, and we distribute this outwards. Now we're going to apply the derivative natural exponential rule over here, and we're going to apply the power rule twice over here because it's inside these derivatives. Once you apply it, the e to the x stays the same. The 3 gets put down on the bottom, and we have 3 minus 2, which is equal to 1 on the top, and over here we should be left off with 2, and that's the answer to this question. Question 4. So over here, we have applied the same rules, and here are the rules, the tools we need to apply to solve this question. So the first step is by applying the sum rule, which we're going to distribute this derivative term inside the bracket over here. Then we're going to apply the constant rule to remove this 8, and we're going to bring it outside. Once we acquire this, we can apply the derivative of the sine function over here, and after we're going to apply the derivative of the cosine function. So basically this would be curved to cosine, and the other will be converted to sine, the negative sine of x. Then we rearrange this like this, and that's the answer to this question. Question 5. So over this question, here are the rules we got to apply to solve it. So we have to apply all these rules. The first step is by applying the sum rule over here. Because we have a derivative term, we got to distribute it. Then once we acquire this, we have to apply the reciprocal identity of the secant function, which is over here. We just be converted to cos of x. And now we can apply the cosine of x derivative and the x squared derivative over here. Now note that this will turn to negative sine of x, right? And over here will be turned to 2 to the x, where 2 minus 1 is 1, and 2 will be dragged down to the bottom over here. And we can rearrange it in a better format, and that's the answer to this question. Question 6. So here's question 6, and here are the tools required to solve this question. We apply all these rules. The first rule is the sum rule. We got to distribute this derivative term to the tan, the 2, cosx. So once we do that, we distribute it. Then we apply the constant rule over here, where we're going to remove this 2 and bring it into the front over here. Then we can apply the derivative of the tangent and the cosine respectively. This would be converted to secant squared of x, and this portion would turn to negative sine of x, and that's the answer to this question. Question 7. So for this question, here are the rules to solve for it. We have to apply a do rule, which is the product rule. So we're going to apply it over here. Then we're going to apply it, and we're going to have this. Now we're going to apply the derivative of natural exponential, which would be left the same over here. Then we're going to apply the power rule. Once we apply the power rule, we get 2 to the x. As I mentioned previously, 2 minus 1 is 1, so the exponent will be 1, and 2 will be dragged down to the bottom. And e to x stays the same. Look at this rule, and that's the answer to this question. Question 8. So the first step is by distributing this e to the x term for every term. Once we acquire this, we go back inside our little toolbox over here, and here's the rules we got to apply. So the first one is a sum rule, because there's a plus symbol, right? So this could be distributed like this. We have this dx term of 2 separate terms. Now we have to apply the constant rule, because we have a 3 over here. We have a constant. We're going to bring it outside. Now we got to apply the product rule, and over here, the reason why we have to apply, because we have a function being multiplied by another function. So over here, we see a multiplication, we got to apply it, okay? We don't have a plus symbol over here. We have a multiplication. So we got to apply the product rule. Once we apply, we acquire this now. Now we gotta apply the derivative of e to the x, which is gonna be a to the x. Then we have to apply the derivative of x to the cube, right? Which would be 3 minus 2 minus 1 will be 2 on the top and 3 on the bottom. And over here will be 2 minus 1 and 2 at the bottom. So we're going to be left off with this. Now we rearrange it. And that's the answer to this question. Question 9. So over here, here's question 9. And this is our little toolbox again. So the first step is by applying the product rule. The reason why you have two functions, you have an x function and a sine function. And they're being multiplied. And that's when you apply the product rule. So once you do that, you acquire this. Now, over here we have the sine of x, which is this rule with the applied to turn to cos of x, and over here will be the power rule, and this can be turned to 1. Now we rewrite it, and that's the answer to this question. Question 10. So over here, here's our toolbox again, and here's the two rules we gotta apply. And the reason why we have to apply a product rule over here is because there's two functions being multiplied. You have a secant function and a tan function, right? And there's no plus symbol, it's a multiplication being done. So we have to apply the product rule because of that. Over here, there's a multiplication being done, we gotta apply the product rule. Once we applied it, we have a derivative of tan, and we have a derivative of secant. Derivative of tan would turn to secant squared of x. And over here, we have the secant, which would turn to secant x tan x. And we left off with this, and that's the answer to this question. Question 11. So over here, we gotta go back at our little toolbox, and here are the tools we gotta apply. So first rule is the sum rule, because you have a function portion over here with another function portion where we could distribute this derivative term. Once we distribute this derivative term, we could apply the product rule over here. And the reason why there's a multiplication being done, as you can see by the rule over here, there's a multiplication by two distinct functions. The f of x in our scenario will be e to the x, and g of x will be secant of x. Now we rewrite it. And now we gotta apply the derivative of secant x, which is this guy over here. Then we have to apply the derivative of e to the x, which is be the same thing, which is this guy over here. And we have to apply the derivative of cosine of x, which is gonna be the same thing over here. So we're gonna have negative sine of x. Once we accomplish this, we get this is the answer. Question 12. Okay, this one, it could apply a little trick to speed it up. And that's the trick right there. We could apply the reciprocal identity cosine rule, where the secant of x could be represented by 1 divided by cos of x. And once you do that, you have this over here. This gets cancelled out. And you do the derivative of 1, which the derivative of 1 is 0. Because it's a constant. It's 0. And that's the answer to this question. Question 13. So this one's similar to the other one we've done previously. So we got to just distribute this e to the x term. And once we've done that, we go back in our little toolbox that we created. And here are the tools we got to apply. The first rule is the sum rule, because you have a plus symbol, right? You have a plus symbol over here, you got to apply the sum rule. You applied it. You got to apply the constant rule because you have a 2 over here. You got to get this thing out of here. So we have this. And now we got to apply the product rule on both sides. The reason why, it's a multiplication. So in this scenario, you have e to the x. E to the x is the function, which can be represented by f of x. And over here, you have tan of x, which can be represented by g of x. And these are being multiplied, so you can apply the product rule. Now, once we apply the product rule, we have to do the derivative of e to the x. Well, e to the x is e to the x still, right? Then we got to apply the derivative of tan x, which would be secant squared of x, okay? Then we got to apply the power rule over here, where 2 to the minus 1 is 1, and 2 will be dropped down to the bottom over here, right? So we'd be left off with this, and we simplify it, and that's our answer. Question 14 over here. The first step is by applying the sum rule. So this is our list of rules, and we're going to apply the sum rule over here because we got to distribute this derivative term inside. And the reason why is because we have a plus symbol, right? And now we can apply the constant rule to remove this constant and bring it outside. Once we've done that, we can apply the product rule over here. And the product rule, the reason why is because there's two functions being multiplied. So e to the x is being multiplied, which is can be represented by f of x, and cotan of x can be represented by this g of x term. Once we understand that, we can then apply the product rule, and then after we could apply the derivative of the cotanx, which cotanx is this guy over here. Then we apply e to the x, e to the x is just e to the x derivative, and over here, this would be just left off of 1 with this power rule. And that's our answer to this question. Question 15 over here, right? So the first step is again our little toolbox again. And we're going to apply the product rule. Why? Because there's a multiplication going on. We have tan of arctan represented by f of x, and cos of x represented by g of x, right? So this is going to apply the product rule over here. We apply the product rule, Now we have the derivative of cos of x will be negative sine of x over here. And after we do arctan derivative, which is going to be this guy over here, we're going to apply it. And once we apply it, we have this. We rearrange it to make it look a lot better. And that's our answer to this question. Question 16. So here we have to apply a new rule, right? Which is called the quotient rule, okay? And over here, how do we tell us the quotient rule, you might be asking? Well, this x²+x+3 represented by f of x over here. And over here at the bottom, we have x to the power of 3 plus 16, which is represented by g of x, right? And over here, it looks very familiar to this guy over here, right? So we're going to apply this rule. And once we apply it, we get this thing over here. It's pretty big. Now we're going to apply the derivative to every single term inside, which is basically the sum rule. We're going to apply it twice. Once we applied it, right, we have to apply the power rule. So over this portion will be 2 to the x. Over here will be be 1, sorry. And over here will be 0 because the derivative constant is 0. Now over here will be 3 at the bottom and 2 on the top. The reason why you do 3 minus 1, which is 2. So 2 is going to be at the top and 3 at the bottom. And over here will be 0 because it's the constant. So now we applied it and we get this. Now we rearrange it. And that's our answer to this question. Question 17. This question, you got to apply the quotient rule. So that's going to be our first step. So here, this is the first step. We got to apply a quotient rule. And the reason why, we have etx represented by f of x. And we have g of x, which is 3 plus x. Now, the reason why is also because we have this dividing. When you see divide, you got to apply the quotient rule. We applied it. Now, over here, we got the exact same thing as before. So over here, we have e to the x, which applied the derivative e to the x. And over here, we have to apply the sum rule because there's a plus symbol. Once we apply these rules over here, we can then do derivative 3, which derivative 3 is basically the power rule. But 3 is going to be 0, and over here will be left off with 1. And then we'll be left off with this, rearrange it, and that's the answer to this question. Question 18. So over here, we're going to apply the sum rule again. Okay? We apply the sum rule, and this one's a bit different because over here, once we finish applying the sum rule, we have this thing over here. You might be scratching your head, how do I do this, right? But don't worry, we gotta apply the product rule for exponents, and this is a basic algebra rule. So this could be rewritten as the following, right? And now we could take this, because this is a constant, bring it outside, okay? And once you bring it outside, then this looks a lot more familiar, right? So this portion over here will be doing the derivative of e to the x, and over here, this portion over here will be left off with 2 to the x because you do 2 minus 1, which is 1, and 2 at the bottom. And that's our answer to this question. Question 19 over here, right? So the first step is by understanding what type of tools we're going to apply. The first tool we're going to apply is the quotient rule. As you can see, there's a division symbol over here. And we have f of x on the top and g of x on the bottom. So we can apply this quotient rule and we acquire this. Now once we applied it, we can apply the sum rule because over here is a minus symbol, which is similar to a subtraction symbol. And over here we have a plus symbol, which we apply the sum rule. Once we apply the sum rule, we acquire this. Then over here we can apply the power rule because these are in terms of power. So this would be turned to 0 and this portion would turn to 1. Now, over here, we apply the constant rule because you have a negative. We're going to bring it outside. And over here, we're going to apply the derivative of the natural exponential rule, right? And we just e to the t. So now, once you apply it, we have to go back over here because we have a derivative over here. And here, these two things are being multiplied. So we have to apply the product rule because they're being multiplied. Once we applied it, we acquire this. And now e to the t is the same thing. And t will be just 1. And that's the answer to this question. Question 20. So over here, we gotta apply these sets of rules. The first rule is the quotient rule, and the reason why you have a function divided by another function, and we're gonna apply the quotient rule. Then we apply the sum rule, and the reason why is because over here we have a plus symbol, and we're gonna apply it once over here. Then we can rearrange and change these square roots, and we can write them like this. We can rewrite the square root as 1 divided by 2. And over here we could do the exact same thing for the 5th root. Now once we've done that, we can apply the power rule on each of these portions. And now once we apply the power rule, and after we simplify, right, and then after we acquire an answer of this. Question 21. So in this question, it's very similar to the previous question, and here are tools we have to apply. So we have to apply the quotient rule first, and over here, the reason why we have to apply a quotient rule because there's a function on the top and a function on the bottom, and it's being divided. So we have to apply the quotient rule. Then we have to apply the sum rule, which is over here, because we have a plus symbol, we have to distribute the derivative symbol. Then we got to apply the radical exponent rule, because we have a square root of 5 and we have to rearrange it. Once we've done that, you can rewrite it again. Then we apply the power rule over here, because it's an x, so this would be 1, right? Then you have to apply it over here, and this would be 1 divided by 5 by minus 1, and you bring down the 1 divided by 5, and over here, you can apply the derivative of natural exponential. And once you've done that, you acquire this. Now after acquiring this, we're going to rearrange the top, and we're going to get this, and that's the answer to this question. Question 22. So in this question, it's very similar to the previous question. We have to apply the quotient rule first, as seen over here. We have to apply because there's a function being divided by over another function. You see a division, so we have to apply the quotient rule. Then once we applied it, then we got to distribute this derivative term because there's a plus, and we have to apply the sum rule. And after we applied it, we acquire this. Then over here, we could apply the power rule because it's a constant. It's going to be 0 this portion. Then you have to apply the product rule because over here they're being multiplied. See, this function over here is being multiplied with e to the x. And when there's a multiplication, it means we have to apply the product rule. Then we have to apply the derivative of natural exponential rule over here to the fact because we have a e to the x. Okay? And once we apply that, we acquire this. And now we got to do it again over here. We have to apply the e to the x rule, which is going to be e to the x. And over here we have to apply the power rule, be 2 at the bottom and 1 on the top. So it's going to be 2x. And that's it. So we're going to get it like this. We rewrite it. We change up the top over here. And we get this as the final answer. Question 23. So this question is very similar to the previous because we have to still apply the quotient rule, the first step. So we're going to apply it. Okay, because there's two functions being divided over here. That's why we have to apply the quotient rule. So we applied it. Then we're going to apply the sum rule over here. The reason why there's a plus symbol, we're going to distribute this derivative term inside. Once we've done that, we can rewrite it like this. Then we go from left to right. So we do the derivative of secant x, which is this guy over here. We're going to apply it to be secant x tan x. And over here, we're going to apply the derivative of the power rule. And the derivative of the power rule over here will be 0 because it's a constant. Now over here, to apply the derivative of the sine function, which would be a cosine of x. Once we've done that, we acquire this. Then we can apply the reciprocal identity for cosine rule, where this could be rearranged like this. So now we could cancel out this cosine of x and cosine of x at the top over here. Once we do that, we acquire this, and that's the answer to this question. Question 24. So this question, you have to still apply the quotient rule. So that's going to be our first step again. Because they're being divided, we have a function on the top and a function on the bottom, and it looks like this. So now we applied the quotient rule. Now we're going to do the derivative of the sine function, which is just be turned to cosine. And now we're going to apply the power rule over here, which is going to be 1, because you do 1 minus 1, and after you bring down 1 at the bottom, it'll be 1. And that's our answer to this question. And here we rearrange it, and that's the answer. Question 25. So the first step in this question is very similar to the previous one. The only difference is we have e to the x. So we still have to apply the quotient rule. And the reason why is because sine of x is basically like f of x and e to the x is g of x. And they're both being divided over here. So that's why we have to apply the quotient rule. Then over here we have sine of x. And we have the derivative of sine of x, which is cosine of x. And over here we have e to the x, which we have to do the derivative, we just e to the x. And that's the answer. We rearrange it, and that's the answer to this question. Question 26. So over here, we have to apply a little unique cosecant reciprocal identity as the first step, right? We gotta convert it, we gotta rearrange it, and we have this. Now from this, we can apply the quotient rule. And the quotient rule, because we have a function on the top, which is x squared e to the x, and on the bottom we have g of x. So we can apply this rule over here. So we're gonna go ahead and start applying it. Then over here we're going to apply the product rule because there's a multiplication going on over here, right? See x squared and e to the x, the multiplications. We apply the product rule. Then we apply the sine rule because we have a sine function, and this is very similar to this, would just be cosine. Now once we do that, we have to apply the derivatives over here because of the product rule. And now we have derivative e to the x. Well, e to the x is just going to be the same thing, and x squared, we have to apply the power rule for that, and after it's going to be 2 to the x. We rearrange it, and that's our answer. So in this question, question 27, there's another way on how to apply the product rule with 3 functions, right? So over here we have 3 functions. We have x to the power of 3 sine x and tan x, right? And we can apply the product rule, but we do it for every single variable. What I mean by that is the following, right? So we apply the product rule, and basically we do the derivative of one portion, and we keep it all the same. Then we do the same thing, and we rearrange, and we take the other portion. Then we do the other portion. And by doing that, we apply the product rule for 3 functions. And now we can apply the derivative of the tangent rule. Then we can apply the derivative of the sine rule over here because we have a sine. And after we can apply the power rule, and once we apply it, we acquire this, and that's our answer. Question 28. So this was a bit different because now we have a little 2 over here and another 2 over here. So by understanding that, basically it means we have to do the derivative twice. So we're going to separate it. So this is how you separate it. So we have a derivative inside and we have a derivative outside, okay? And by doing that, we can apply our derivative rule. So we can apply the sum rule because we have plus symbols. We apply it. So we're going to go ahead and start applying it. And once we apply it, we could do the derivative of this portion over here, which is going to be a power rule, and the derivative of this, because this is going to be a power rule 2, and this is going to be 0, and this will be 2x. And now we can apply the derivative of the sine rule, which would be cosine of x. So once we do that, we acquire this. Now we got to apply the derivative again, which we have to apply the sum rule again. Then we're going to do the constant rule here. We got to remove this 2 and bring it outside. Then we apply the derivative over here, which is going to be negative sine of x. Once we do that, right, we do the power rule again. This can be 1, and that's the answer to this question. So this is question 29, and this one's very different because we have to do a derivative 99 times, which we can't be doing that, right? It's going to take a long time. So basically, we're going to rewrite over here, and we're going to extract one derivative. So we have 98 still remaining, and we extract 1. We have to try to find the trend to solve this question, right? So once we do that, we do the derivative of this, which the derivative of this would be just cosine of x, as shown over here. And we write down 1, because this is our first trial, right? Then we go again, we do it again. So we take out that little portion from that 98, and we take that little derivative over here. And after we do the derivative, and we get negative sine of x, and that's our second trial. Then we do it again. So we rewrite it, we take the derivative outside, we do it again. So we're going to take out a little portion of that derivative again. We're taking it out. We do the derivative, it's going to be cosine of x. And this is going to be trial 3. Now we do it another time, right? And once we do that another time, we're going to do the derivative again. And we acquire this, and we rearrange it to sine of x. Now, we got the same from where we started. So now we completed the circle, right? And now we got to find the remainder. So we basically do 99 divided by 4. And we get a 24 remainder 3. So by understanding that's remainder 3, it means that out of 99, when we do 99 derivatives, we're going to acquire an answer of this one, this trial 3. So our answer is really of this is negative cosine of x. And that's our answer to this question. Okay, so this is question 30 now. And we're going to be applying a new rule that we haven't seen from the previous questions, which is the chain rule. And the reason why we have to apply a chain rule over here is the following. We have a function inside of another function. See, we have 92, then we have a function inside. And basically, we have to rearrange it in this way. So we know that y, right? Y is the whole function, right? It's basically the whole thing. So the whole thing is what? It's this. It's x3 plus 2 to 92. And we know that u, or g of x, is basically what's inside. And what is inside of here? It's x3 plus 2. So we write it over here. Then we write over here. This is what the rule we're going to apply, right? And now we got to create the equation. Now we put this y, we substitute it in. So it's x3 plus 2 to 92. And it's in terms of u. This bottom part tells us it's in terms of u. So we got to substitute this u variable inside. And once we substitute, we get u equals to 92, right? And after, you got to do the same thing for the du portion over here. And the du portion, we got to substitute this g of x. And now we rewrite the equation like this. We do the derivative. So this is in terms of u. So this, we have to apply the power rule first and after the sum rule. So we apply the power rule, then the sum rule. And this portion would just be 91 and 92 to the bottom. And over here, we're going to do the derivative x to the 3, which would be 3 at the bottom and 2 on the top. And this is going to be 0. So we're going to acquire this as the answer for this portion. Then we have to use back substitution to change the u term into x's, because x's was originally started in the problem, so we got terms in x's. We use back substitution, basically we substitute this u part, And that's the answer to this question. Okay, so this is question 31. And this one we're going to apply the second variation of the chain rule, but the first step is by applying the product rule because you have two functions over here being multiplied, as you can see. So we're going to apply the product rule and we get this thing. Now we're going to be like, we have to apply the chain rule. And we apply a chain rule on both sides over here. And first, the first portion of the chain rule, we apply the derivative. The reason why I have to apply the derivative of the power rule is because with the first of the function on the outside, look at the rule over here. So if you see this, then we're going to apply the derivative of the outside, then we're going to apply the derivative of the inside. So first the outside, and the outside over here will be a minus 1, right? Which would be 7 on the top still, and it'd be left off with 8 at the bottom. And as you can see, this is how we apply it. And now we have the derivative of the inside that we have to do. And now we have to apply the sum rule because we have a plus symbol. We extend it like this. Then we're going to apply the power rule to each individual over here. Once we do that, we acquire this. We rearrange it, and that's our answer to this question. Question 32. So in this question, we're going to apply the chain rule. And the reason why I have to apply a chain rule, we have a function inside of another function. And the function that's inside of another function, so we have the first function, which is e. Then we have a function inside of that, which is 2 plus cos of x, right? And now we got to rewrite it in terms of that. So basically, our y is the whole function. It's the outer function, which is the f portion. We can rewrite it like this. And the interior portion is 2 plus cos of x. Once we rewrite it like this, we can apply the chain rule. And we apply it over here. Now we got rearrange this portion. So this y term could be represented as this. So basically we took the function, so the y portion, which is this guy over here, which is e to the 2 plus cos of x, and we substitute a u because it's doing the derivative in terms of u, so we got to put a u term over here. Now we got to do this portion where we got to do the same thing. So we got to substitute the u portion, which is be 2 plus cos of x, but it's already in terms of x, so we don't have to do any substitutions. Basically, we put it over here and we get this. Now we got to do some derivatives. So here are the rules we got to apply for the derivative. The first derivative we have to apply is the e to the x rule over here, which would be left off of the same thing. And over here we got to apply the sum rule because there's a plus symbol. Once we do that, we acquire this. Now we do the derivative of cos of x, which this guy over here will become negative sine of x. And over here it will be 0 because when you take a derivative of a constant, it's 0. And we rearrange it, and that's our answer to this question. Question 33. So for this question, we have to apply the chain rule, but this one's a bit different because we have a function inside of another function. What I mean by that is that we have to apply the chain rule 3 times. So the first step is by identifying the outer function, and the outer function is the whole function basically. Then what's inside of that is our u, right? And our u is what's the next interior function. And the next interior function is cos of secant x, right? Then the next interior function of that is secant x. Once we accomplish this, then we could rewrite it in terms of this because now we're doing these individual portions over here. So now we're going to do the dy du portion. The y, as I shown over here, is this guy over here. And it's in terms of u, so we got to substitute a u inside. And the u is cosecant x, so we could just replace that with a u. Then we have to do for the next one. The next one is u. So now we look at u. Okay, cosecant. We put cosecant. Oh, in terms of t. So now we got to substitute this t portion, which is secant x. So we have to substitute it, which is just going to be a singular t. And then after we do it again with this one, which our t is secant x. And this one you don't have to substitute because you have an x over here. And we have to be left off with this. And now we can apply the formula. So we got to apply this portion over here, this portion over here, and this portion over here. Now we get this. Now this is a lot simpler. And we got to apply our derivative rules. So the first derivative rule we have to apply is the sine rule, which would be cos of x. Over here we got to apply negative sine of x. And over here you apply secant x, which would be secant x tan x. And we acquire this. Now you got to do back substitution, which means that you see this t term, we got to resubstitute the secant x. And after this u term, we got to substitute this cos secant x. Now once we do that, we can rearrange the equation. And that's our answer to this question. Okay, so this is question 34, and it's a lot more simpler than the previous one, right? So the first step is by applying the chain rule again. So we're going to apply the chain rule again, and as I said, there's a function inside another function. We have the cos function, we have the 4x squared function. And the main function, the outer function, is cos 4x squared, and the inner function is 4x squared. Now we're going to do this incremental portion, which is dy divided by du, where the y is represented by cos 4x², and we got to substitute the u because we're doing it in terms of u. So we got to substitute the u, and in this portion over here, this du divided dx portion, we got to put the 4x², and we don't have to do any substitution because we have an x over here. Now, we got to apply everything inside this formula. Once we do that, we get this. And now, we can apply our derivative rules. So the first derivative we're going to apply is the cos rule, where we convert this to negative sine. And the next rule is the power rule, where this is going to be turned to 8x. Now, once we do this, we can apply back substitution. And that's our answer to this question. Question 35, and the first step is by rearranging this portion, because we have a 1 divided by something, we can arrange it with a negative on the upper exponent over here. Now, once we do that, we have to apply the chain rule because we have a function inside of another function. Now, the outer function is this, so basically the whole function, and the inner function is what's inside, so it's 1 plus sine of x. Now, we gotta redo every little incremental portion over here, and this portion would be, well, we know the y is 1 plus sine of x to the power negative 2, where this could be represented by u because it's in terms of u, and in this portion we could rewrite it simply, and we don't have to substitute anything. Now we substitute it in, then we can apply our derivative rule, so we have the power rule, sum rule. So the first one is the power rule over here. So basically this would be negative 2 at the bottom and negative 3 on the top still. And over here we got to apply the sum rule because there's a plus symbol. So now once we acquire this, we could do the power rule again over here. And after we could do the sine rule, which would be cosine of x. Now once you do that, you acquire this. You use back substitution to substitute the u term, which u term is 1 plus sine of x. And you acquire this as the answer. Question 36. So for this question, you got to apply the chain rule because we have a function, an outer function, inner function. So the outer function will be this. And the inner function would be this. So now we can rewrite it like this, where we could change this to u because we're doing it in terms of u, which is du. And this portion, we could change it. We could just substitute the u, and in terms of x, we don't have to do anything special over here. Basically, now we put everything we know inside. And now, here are our derivative rules. We have to apply all these derivative rules. The first we're going to apply is a general exponential rule for derivatives. And we apply it over here. And over here, we got to apply the constant rule to move the negative. And after, we have to apply the power rule. So over here, we got to do the power rule. Once we apply the power, we get this. And now we got to do back substitution to change this u term. And the u term will be negative 1 divided by x. And once you do that, that's the answer. Question 37, we got to apply the chain rule. And the chain rule, we have to first establish that the y is the outer function, which the outer function is this, and the u is the inner function, right? And after we rewrite it, so we basically take this little portion, we put the y is this, and we substitute the u inside because in terms of u. Now here we gotta do the exact same thing for the g of x, the u portion, we substitute this in, and then it's ready in terms of x, so we're fine. We rewrite it like this. Then we do the necessary substitutions, and we acquire this expression, and we gotta do our derivatives. So the first derivative over here is obviously the e to the x rule. Then over here we have to apply the product rule because there's a multiplication going on. When there's still multiplication going on between two functions, we gotta apply the product rule. Then we get this. Then over here we gotta apply the power rule over here. And over here we gotta apply a chain rule. And in this chain rule, we're gonna be doing it a bit differently. We're not gonna be doing this whole procedure. I'll show you a shortcut on how to do it. So the shortcut is doing the function that's on the outer, then doing the function in the inner. So now we have to do the sine rule. And after you take that function outer and you put it on the side as shown over here, and we gotta do the derivative of it. And the derivative of this is gonna be the power rule. So we do basically the power rule, we acquire this, and that's our answer to this question. Question 38, and here's our little toolbox. So now we're gonna apply the chain rule, but a bit differently. So basically we're doing the shortcut. Basically the shortcut is you do the derivative of the outer, you take the inner, and you do the derivative of the inner, then you continue that procedure. And for this portion, we're gonna do first the secant, so the derivative of the secant. So the derivative of the secant is secant x tan x, and we're going to have tan and 4x inside too. So you see over here. And after we do the derivative of the inner, so the inner was tan 4x. So now we got to do derivative. So basically we got to do derivative of the tangent, which is secant squared x. And after we have to do it again because we have a derivative inside the inner function, right? So basically we get this. And now we got to do the inner portion, which is 4x, which basically is our the h derivative over here, and now we got the derivative of this, which is before, and after we rearrange it, and that's our answer to this question. This is question 39 now, and the first step is to obviously apply the chain rule. I'm going to do it the other way, where we do the derivative of the outside, then we do the derivative of the inside, okay? But before we do that, we have to change this up a bit. What I mean by that is going to represent the square root by 1 divided by 2. And the next step is by removing this 8 because you have a constant inside the derivative. So we're going to remove the 8. We're going to bring it outside. And now we could derive it on the outside. And the derivative of the outside would be this 1 divided by 2 term. And we're going to do 1 minus that. We're going to bring the 1 divided by 2 term on the bottom, as shown over here. And once we do that, we could do this little simple multiplication over here, which is before. And now we got to do the inside, where we have to apply the sum rule. And once we apply the sum rule, well, this is going to be 1 over here. And now over here, we have to remove this 4 because the 4 is inside of here. We're going to remove it. It's a constant. We're going to bring it outside. Once we do that, we can apply the derivative of the power rule. And after we acquire this, we rearrange it. And that's our answer to this question. Okay, so question 40. This question is very similar to a previous question we have done. And the first step is by applying the chain rule, but we're going to apply it in a different format. As I mentioned previously, we're going to continue doing the format where we do the inside, then we do the outside, instead of substituting it by a u variable, which is the quicker way. So the first step is by applying the general exponential rule because we're doing the outside function. And the outside function is 8, okay? So we apply it. So basically, we keep the base 8, and after we keep the top portion, because it's our g of x, and after here we do ln 8, and after we do the derivative on the top portion. Now, the top portion, we got to apply the sum rule, right, because there's a plus symbol, and after we do derivative of this portion, which would be the power rule, and the derivative of this portion would be the another power rule. This can be 0 because it's a constant, here will be 2x, and we rearrange it, and we get this as the answer. This is question 41, and this one is a lot simpler than the other ones we've done previously, and we basically have to apply a product rule because there's a multiplication going on over here, right? We have two functions being multiplied. We apply the product rule, and the cotangent of this derivative will be the negative cosecant squared x, and this portion over here will be negative cosecant x cotan for this portion. And after we acquire this, we rearrange it, and that's our answer. Question 42. So for this question, here's a little toolbox, and the first step is by applying the quotient rule. And the reason why we have a function being divided by another function, right? We have this f of x portion on the top, and we have this g of x. So we applied it. Here we got to apply the sum rule because there's a plus symbol. And over here we got to apply the derivative of the cotangent, and it'll be negative cosecant squared of x. Once we do that, we got to apply the derivative of the cosecant x, which is basically this guy over here. And over here we got to apply the power rule, and this would just be 2 because you're doing 2x, it'll be just 2, and you acquire this, and that's our answer to this question. Okay, so this is question 43. The first step is by applying the chain rule, right? And also, we're going to do the second format where you do the inside, then we do the outside of the chain rule, as shown over here with this formula. Then, we have to derive the cotangent. So basically, we're going to acquire this. And the reason why we acquire this, as shown in the formula, you derivative of the outside, which is just going to be negative cosecant squared of x. Then you take the inside and we bring it and we try to do a derivative of it. And over here, we got to do derivative of the product rule because there's two functions being multiplied. Once you do that, you reestablish this. And now over here, we got to do the power rule because it's just x to power something. And over here, we got the cos of x rule. And it's over here we get negative sine of x, and over here we're going to have 1 divided by 2 on the bottom, and we have negative 1 divided by 2 on the top. Now once we do that, we rearrange it, and that's our answer to this question. Question 44, and over here we got to apply the product rule, because we have a function being multiplied by another function, right? Then, over here we got to apply the arctangent formula, or the inverse tangent rule, and once you apply it, we have to also apply it over here for the arccotangent, right? And we can acquire this. And once we acquire this, we can rearrange it to a more familiar format. And that's the answer to this question. Okay, so this is question 45 over here. And we have to apply the quotient rule because there's a function being divided by another function. As you can see over here, we apply the quotient rule. You got to do the derivative of the arctangent or the inverse tangent. And the next step is by applying the sum rule here because we have a plus symbol. So we require this, and now these two things get canceled out, and over here we gotta apply the power rule for both of these. So this would be 0 because the derivative of constant is constant, it's 0, and the derivative over here will be 2 at the bottom, and x would be a singular 1 on the top, and you acquire this, and that's the answer to this question. Question 46, and the first step is to apply the product rule. The first step is to apply it because we have a function being multiplied by another function. Then we have the arccosine, which we have to apply this rule for, and over here the cosine of x. So basically we have to apply this rule, which would be negative sine of x. Once we apply these rules, we acquire this, we simplify, and we get this as the answer, and that's it for this question. Question 47. So over here we apply the chain rule, and the reason why we have a function inside of another function, and by applying this chain rule we gotta apply the derivative of e to the x as well. So we do the derivative of e to the x, which is gonna be the same thing, and after we do the derivative of the inside, so we go outside then inside, so we have to do the derivative of this portion. This portion over here, pay attention, you gotta apply the product rule. The reason why you have a function being multiplied by another function, once we establish this, well, this portion over here we have another chain rule, so we have to apply a chain rule again. And here we have the derivative of the cotangent, so we gotta apply the derivative of the cotangent, which is the outer function. Then we have to move into the inner function, and over here we apply the derivative of x. Well, this would just be simply 1 because the power rule. Now, once we accomplish this, we gotta do it over here. So basically, we have to apply the sum rule, and we acquire this huge expression. And now we gotta do the derivative of x to the 3. Where x to the 3 would be 3x to the power of 2, and over here would just be a constant root, so we gotta remove the 2, and after we apply the derivative of x over here, it's gonna disappear, and we acquire this as the answer. Question 48, and the main thing to do, the first step actually is to apply the product rule. The reason why we have a function being multiplied by another function, now we gotta do the derivative of this portion. This portion over here, we gotta apply the chain rule, and after we have to do the derivative of the outside function, which would be sine, and we move on to the inner function afterwards. Then over here we gotta apply the derivative of secant x, which is be secant x tan x. So we acquire this. So as I mentioned previously, this will be turned to a cos because we need the derivative of sine. And we take the inner portion, we have to derive the inner portion as shown over here by the chain rule. And after we have to apply the constant rule to remove this 4, then we could do the derivative of x, which would be applying the power rule, which we just get 1. And after we end up an answer of this. Okay, so for this one over here, it's a lot more different. And what I mean by that is you have an x to the power of x, and you could be scratching your head right now and be like, how do you do this, right? So the first step is to try to rearrange it, try to get into a different format, and the way to do that is by applying the logarithmic exponential rule. And this rule basically states that we could substitute this ln term, which could be cancelled to 1, but we could substitute it so we could rearrange the equation. So we could substitute it. Let's substitute it. So basically, we get this, and now we could bring down the x. So now we get something like this. Now, this looks very familiar of a chain rule. So we can apply the chain rule, and then the first step is to do the derivative of the e. So we do the derivative of the e, and after, we have the derivative of the inside, which is x ln x. And x ln x, you could basically apply a product rule, as we've seen before. And these are all the other derivative rules we gotta apply over here. So over here we have the derivative of ln x, where the derivative of ln x we can apply this, and basically do 1 divided by x, right? Because that's the function inside, and after the derivative of x is 1, right? And over here we can apply the derivative of x, which is just basically 1, and we acquire this as an answer. We cancel these two things, and we acquire this as the final answer to this question. This is question 50. And now here are the rules you gotta apply. The first rule is the product rule of a function being multiplied by another function. So once we establish that, we got a derivative of ln of x, which is this guy over here, which is be 1 divided by x. And over here we apply a derivative of x to the 4, where 4 become onto the bottom, and we have x to the 3. So we accomplish this, and we cancel out the x's, and we acquire this as the answer. Question 51. For this question, you have to apply the chain rule because you have a function within another function, and our f will be represented by cos, and our g of x will be represented by ln x to the 4th. So basically, we have to apply this rule. Then, to do the derivative of the cos, we have to apply the derivative of the cosine rule, which is negative sine of x over here. And now let's rewrite it. So basically, we change this to sine, and after we take the inner side, we got to derive the inner side. And that means we have to apply the derivative natural logarithmic rule, where the x⁴ become on the bottom, and then we take the derivative x⁴. And we have to use the power rule to do this. So we're going to have 4 on the bottom and 3 on the top. And as we left off with, then we can cancel out this. We have only a singular x on the bottom, and we're left with this as the final answer. Question 52. Over here, we have to do a product rule. So we go inside a little toolbox, and we have to apply the product rule. And the reason why we have a function being multiplied by another function, so we separate this. So we basically have cotan of x multiplied by this ln portion, and that's our f of x, the cotan portion, and our ln portion, our g of x. So we have to apply the product rule. Once we apply the product rule, we could do the derivative of the cotangent, which is basically this. And after we have to apply the ln rule over here. Okay? So basically we have to do this. Basically, sine x² will be at the bottom, and after we're going to do the derivative of sine x². So we left off with this. Then we go back at our little toolbox, and we got to do the chain rule because we have a function within another function. We have a sine function within x², right? So we got to apply the chain rule. Then the outer function, we need to apply the derivative of the sine rule, which is going to turn to cos of x, and we rewrite it. So basically, we have cos of x here now, and now we got to do the derivative of x². And the derivative of x² is basically we have to apply the power rule, and this comes 2 on the bottom, we have 1 on the top, like shown here. And after we write it, and that's our answer to this question. Question 53. For this question, it's a bit different, where we have the log instead of ln, and you still have to apply a product rule because our product rule. And we're going to show it over here in our little toolbox. So here's the product rule, and we have to apply it because cosecant of x is represented by f of x, and this log portion is represented by g of x, and they're being multiplied, so that means we have to apply the product rule. Once we apply the product rule, we have to do the derivative of the logarithmic rule, which is this guy over here, right? So f of x is basically x⁴ we put on the bottom, and it'd be ln 7 at the bottom, doing the derivative of x⁴. And after we do the cosecant derivative, which is basically this guy over here, we have cosecant x cotangent. So basically we write it like this. And now we got to do the derivative of x⁴ as shown over here. So we got to do the derivative of it. So we basically have to apply the power rule. 4 will become on the bottom and 3 will be on the top. And we left off with this. This gets cancelled out over here. And we left off with this. And that's our answer to this question. Question 54, and this one's very similar to the derivative of x dx, and we apply that little rule that we knew beforehand. So let's go to our little toolbox and let's discover that rule. And this is this rule. So basically, we're going to add this ln term inside of the equation, and this ln term makes it solvable. And ln, when you add it to this function, doesn't change the value of the function because this could be just cancelled out. So we have to add this term to make it solvable with our rules. So basically we add it over here, and after we have to take this cosine of x and bring it on the bottom, and now this looks a lot more familiar. And by understanding this, we can apply the chain rule. And the reason why we have a chain rule is we have a function within another function. Our f is basically this e portion, and our g of x is this whole thing upstairs over here. So basically we gotta apply it. So the derivative of natural exponential rule is basically e to the x. Okay, so basically this portion should be e to the x, and after we have to do the inner portion. So basically this is the outer portion. We did the derivative, it's just the same thing, and now we gotta do the inner portion. This over here, you gotta apply the product rule, and the reason why you have a function being multiplied by another function. So here you have the cos of x represented by f of x, and this ln portion represented by g of x. So here we write it, and now we have to pull out another little toolbox. And the next step is by applying natural logarithmic rule for derivatives. So basically the sine will be on the bottom, and you have to take the derivative of sine. Okay, and now here we have to take the derivative of cosine of x because we have to do the derivative of it, and it will turn to negative sine of x. So let's do it. So now we have basically this, and now we got to do the derivative of sine of x, which just become cos of x. Now from this we can simplify, and that's our answer to this question. Question 55, and it's very similar to the previous question we have done. So basically, we apply that little rule that I told you about before. And that little rule is this rule here. We have to add this ln term, and this ln term makes it solvable, okay? So we're going to apply the ln term, and once we apply this ln term, we have to rearrange it so we bring down this cot of x down. So we're going to bring this cot of x down, and that means we have to apply a chain rule because we have a function within another function. Our f is represented by e, and our g of x is representing the inner portion, which is cotx, and ln tanx. So we're going to apply that, and after we're going to apply also the derivative of natural exponential rule to the outer function, and we acquire this. It's going to end up being the same thing, and now we're going to derive the inner portion. The inner portion, we're going to apply the product rule because there's a function being multiplied by another function. We acquire this, and now we got to go back into the little toolbox, and we got to apply a derivative of ln, which we have tan of x on the bottom. We're going to do derivative of tan of x, and over here we're going to do derivative of cotan of x, which would be just negative secant squared of x. Excuse me. And now we got to do derivative of tan of x. The derivative of tan of x is secant squared of x. So we basically rewrite it like this, and I have to rearrange the equation, and we end up with an answer of this. Question 56, and this one's, we have to apply a quotient rule because we have a function being divided by another function. So over here we have to apply the quotient rule. So once we apply the quotient rule, we have to derive the cotangent. So it's basically this guy over here, which should be negative cosecant squared of x. And after we have to derive of arccosine, which is basically the inverse of cosine. And we end up with this guy over here. Now once we do that, we rearrange the equation, and our answer is this. Question 57, we gotta apply the quotient rule because we have a function being divided by another function. And we have to apply it. So once we apply it, we have to derive the tan x portion over here, which is just be secant squared of x. Then we gotta apply the chain rule, and the reason why we have to apply a chain rule, we have a function within another function and a function within another function, and we're gonna apply it 3 times. We're gonna do 3 derivatives. Now note that f is represented by cotan, then secant is represented by g, and sin of x is represented by h. And right now we can do derivative of cotangent of x because that's the outer function. So outer, then inner, okay? So basically we apply, which is negative cosecant squared of x. Now we got to do derivative of secant x over here, which is basically represented by this portion over here from the chain rule. Now we do the derivative of the secant rule, which would be secant x tan x, okay? Then we have to derive a sine of x, which would be cosine of x. Now once we've done that, we rearrange the equation, and that's our answer to this question. Question 58, and for this question over here, we gotta apply the derivative of natural logarithmic rule right away, because as you can see over here, we have the ln, and to do the derivative of the ln, we gotta apply this rule. And this portion over here, this whole portion over here, this x3 to minus 8x² plus 12x plus 2 will be on the bottom, and then you do the derivative of that. So basically we end up with this. We have to apply the sum rule over here, right? Because we have a plus symbol, even a minus, we have to distribute. Now once we did that, we could remove this negative by applying the constant rule over here, and over here too. So we apply the constant. Then we got to apply the power rule over here, and over here, and over here, and over here. So basically, x3 become x squared, 3x squared. Then over here will be 2x. Then over here will be just 1, and here will be 0 because you're doing a derivative constant. So it's going to be 0. And basically, we end up with this. We rearrange it, and that's the answer to this question. Question 59, and the first step is, don't get scared by the square root. The first step is always by replacing the square root with a 1 divided by 2 as an exponent, okay? Now, once we've done that, we could apply the chain rule over here. And the reason why I have to apply the chain rule is because we have a function within another function. And the f is basically this 1 divided by 2. And the g of x, which is this ln 9 cos of x, basically, okay? So once we've done that, we can apply the power rule over here. Once we apply the power rule, we acquire this. And after we derive the inner portion, basically this g prime of x over here, basically g derivative of x. So now we got to apply it. We apply the derivative over here. So basically this cos of x will be put on the bottom. Then we ln 9, then the derivative of cos of x. So basically we've done that over here. Now I got to derive cos of x, which is this guy over here. We end up with negative sine of x. And then we rearrange the equation, and we end up an answer like this. Question 60. And for question 60, we got to apply this rule over and over again, which is this rule over here. So basically we're going to have ln x squared at the bottom, then we're going to do derivative of ln x squared on the top, okay? Then we got to do it again, so basically we're going to have ln x squared on the bottom, then we're going to do derivative of ln x squared at the top. So we end up like this, and then we're going to do it again, so basically we have x squared on the bottom, and we have to do a derivative of x squared. And now we can apply the power rule, because we have x squared, so there would be 2 on the bottom, and x on the, it'd just be a singular x. And now we cancel out these x because they're similar. We cancel them out. And after we rearrange it, and that's our answer to this question. That's it for this video. So please leave a like and subscribe. And I hope you guys have a wonderful, great day.